This is okay? I'll feel like a wedding day singer, but still. Okay, so I've been an Android developer since 2008. For those of you who were working in 2008, you know that it was before the introduction of the first Android phone. I've also started working on Android-based tablets about 6 months before Samsung released their tablet version. And I've been working on Android TV for 4 years, so I'm 3 years ahead of Google. I have a tendency to do these things before them. My specialty is A-standard platforms in Android, which means that I am very well versed in the kernel version and upwards, but my main work is application, just like any application developer. I've been a co-founder of GDG. You know what GDG is, right? Anybody here doesn't know what are Google developer groups? Okay, I would guess that either all of you know them or none of you understood the question. So I formed the Google Developer Group in Herzliya, which is a city in Israel, a couple of years back, and I did a lot of community work in speaking and blogging and performing and doing events for Android. And for all of these things, Google noticed me, and I was propositioned to join the Google Developer Experts Program. Now, how many people know what is the Google Developer Experts Program? Like 4 people. That's excellent. The Google Developer Experts Program is especially for people like me. I am not a Google employee, which means when Google, excuse my French, fuck up, I can tell you that because they don't pay my wage. But I am good enough in that technology, and I have enough experience, and I know how to talk as well as what I'm talking about in order to... And it came back. In order for them to trust me and give me this title that I'm a developer expert. So that's a program. I've been a part of it for the last 3 years, and if you want to join and you think you have enough merit, come talk to me later. The people who actually pay me money are the people who make these things, which is an Android-based set-top box for an OTT solution. If you did not understand what that means, kudos, and neither did I. But I do the Android-based set-top box and smart TV. That's why I said I'm doing Android TV for 4 years before there was an Android TV. So let's start with motivation. What do I want you to learn? What would you want to take away from this presentation? So whatever application developer usually wants is a great user experience, which means smooth applications, smooth UI, sleek transitions, mainly so that the user will be immersed in the experience and will not realize that he's on an application staring at his phone at a bus stop while people are passing by. So one of the reasons in order to achieve that is hardware acceleration. Now, I've thrown this term a couple of times, and I'll continue to throw it. But before I'll continue, I'll start by asking you what it is. So hardware acceleration is simply rendering the graphics on whatever screen you're looking at with the GPU, which is the graphics processing unit, and not the CPU, which is what the entire computer works on. In Android, it means that Google took the canvas, the old canvas, and instead of implementing it in software, they've implemented it with OpenGL. OpenGL speaks directly to the GPU. That means that the rendering has got a lot faster. Project Butter, which was introduced 2 years ago, was to showcase that ability. That's exactly the point. So, as opposed to drawing it with a CPU, which is the software drawing model, the new one is using the GPU or the hardware drawing model, which says absolutely nothing. So, the software drawing model does 2 things. They invalidate the hierarchy, and then they draw the hierarchy. While the hardware drawing model invalidates the hierarchy, records and updates something called display lists, and then draws the hierarchy. Exactly. You have absolutely no idea what I'm talking about. And that's part of the point. That is why most developers don't know how to use hardware acceleration, and they either avoid it, and then some of their apps simply crash and do weird things and they don't know why, or they're trying really hard to cancel it, which makes their apps a lot choppier with a much worse UI than it should be. So this is exactly why this presentation is important. It's not sexy, it's not popping, but if you don't know what you're doing with hardware acceleration, your app is going to suck, which you don't want to. So point number 1, uninvalidate, meaning when invalidate does. So when you're doing it on software or the CPU, the calling items, the actual view where you called invalidate gets redrawn, which is cool, that's what you wanted. But any affiliated item is also redrawn. That means child views, which is kind of okay, but also sibling views. Why? Because if you have a calling to one method that might invoke a pointer to another view, it's being redrawn whether you meant it or not, which is not that efficient. And the command is done instantly. Why? Because you said invalidate now. There's absolutely no other parameter for it to understand when, so it does it immediately. You're saying, cool, it is my creation. I commanded this command. I want it to be done now. Well, that's not very good, and I'll explain why later. In the hardware on invalidate, the calling items drawing is saved to what we call a display list, and you don't need to know what it is. It's just another list on the side. The display list is updated with that changes in mind, and then you just draw the difference. And it seems a lot more efficient. You're saying, yeah, I'll do it all the time. But most mentoring session that I have done with people saying something just stopped working, this view is not being updated, and I don't know why, is because they didn't know that. They implicitly relied on the fact that everything is updated. And then something stopped updating. And then I said, okay, why don't you do an invalidate here in this view? And he said, because I didn't do it before. Well, that's the reason why it stopped working. Okay, just one point. As you may have noticed, I do not stop talking ever. So if you have questions, simply raise your hand or start talking. I'm Israeli. That's how we do it. We have no manners whatsoever. Okay? So that's my deal for you. This command is done on something called the hardware sync or the vsync, which means absolutely nothing. The point is that because the GPU works in interval, the magic number you want to achieve is 60 FPS. Why 60 FPS? Because in 60 frames per second, the human eye is incapable of distinguishing whether the animation is fabricated or real. So you want 60 frames to be changed per second. That means that a new frame must appear every 16 milliseconds, unless I am absolutely incapable of arithmetic. You can test me on that one. So programs which use hardware acceleration have a vsync. Every 16 milliseconds, if you do not make the vsync, you will not be updated. And that means that the human eye will be capable of noticing jank or crushing or whatever. So that is bad. So you're saying, okay, last command ran instantly, which is good. Well, no, it isn't. Because if you run a few commands simultaneously, the CPU doesn't know which one to draw. So it still gets jank, even more. Because you do not have a specific set of rules to work on, more people will be mistaken. It's like if everybody drove on the streets but there were no rules, then nobody will be a felon because everything is allowed. But there will be far more accidents because nobody will know what to do and what to expect. That's the exact same analogy that I usually make. So on the new uninvalidated, non-invalidated views are not refreshed. As I said, that's good because it's much more efficient, but it's bad because you implicitly relied on the fact that they do. So now some things stop working and you have no idea that it's a hardware acceleration, they just stop working magically. Timing is better. Again, because there are rules, you have far greater chance to reach 60 FPS. That's why animations are better. That's why the quality of the UI and UX since hardware acceleration was introduced is exponentially improved. You see far less complaints regarding the animation is not that good. These kind of claims resurfaced after the latest API release because the latest API release had bugs in hardware acceleration, but you can't win all the time. Generality versus expertise. If anybody knows what that means, raise your hand. I specifically choose words so that people will be interested because they have no idea what I'm talking about. So the CPU is a jack of all trades. They do everything by computation. So they'll do everything in the system okay, and some things really great. Graphics, they will do pretty poor. Why? Because they're not very experienced in graphics, and graphics is very, very intensive. So when you have a specifically designed hardware component and software APIs which do that very particular task much better, rendering will be much better. So using hardware acceleration is good. Excuse me. Resource availability. It's like a checkout line. When you have one cashier handling all the clients, you'll move slower. But if you'll have another cashier who just handles deals which are above $1,000, why? Because they are your most valued customers. You want them to get in and out as fast as possible so they'll come back and buy more. So that is the GPU. You have a separate resources, so the queuing for the graphics, which is what the user thinks of best, are handled better, faster, and more efficiently. So you say, okay, cool. You convinced me, dude. Everything should be accelerated. It's the best thing ever. So why are we talking about it? Why do I need to know anything about it? Well, there are a few pitfalls, like everything else. First of all, hardware acceleration is not supported all the way back. It's not backward compatible. API level 11, which is some sort of gingerbread, does not have it at all. Honeycomb, which is pretty old but exists in a lot of markets, especially in Eastern Europe, Southeast Asia, South America, Africa. They have a lot of these API levels. They have it available, but it's default off. And if you're lucky enough to only have clients in Eastern Europe, United States, England, and Japan, which means that all of your clients, or 99% of them, have an API level upper than 14, then you have it and it's default on. Wait a minute. Default, meaning that you have an API to disable it. Why? Doesn't make any sense. If it's that good, you should be able to just keep it on all the time. So API level support is one thing, but also hardware acceleration dictates a higher amount of RAM for many reasons which are too boring to say here. So if at the time that this was introduced, which was Honeycomb, the main device for Android was the Nexus S, which only had about half a gigabyte of RAM, which was not enough. And the dominance in the market was the Samsung G1 or G2, which had even less, meaning that if you turn on hardware acceleration, the device will burst into flames or something. It will not be that good. So instead of doing the Apple way, which says this is the new API, either use it or buy a new phone, Android decided to go another way, saying you will only use it on devices which are capable of using it, which is a good way in my opinion. Second thing is, not all operations are supported. As you may recall, I told you that hardware acceleration is implemented. By the way, you're too quiet. I'm used to Israelis talking and yelling. Are you with me? Are you okay? Is my English clear? Everything okay? Okay, cool. Just my insecurities. As I said, OpenGL implementation of the Canvas operations is the basis of hardware acceleration in Android. Now, if any of you ever implemented an OpenGL, it's a pain in the ass. So it takes a lot of time. And you have to do it for every CPU and GPU separately. No, not every, but most of them, because they're not implemented exactly the same. So when it started in API level 12 and 13, they only did what's good for the system. In ICS, it was a little bit better because they infused that logic into views. And then they continued on and on and on. So it very much depends on what GPU and CPU your user's device are using and what API level in order to know if your animation will work or not. It's very similar to NDK developers. When they release games for NDK, they have to test it on each CPU and GPU family. Now, it's not as severe as an NDK, but it's the same pattern. So, by the way, that's a good tip. If you're having trouble and you're thinking it's hardware acceleration, use the same QA patterns that NDK users use. It's on all Android gaming forums. You have these patterns. What are the families of GPUs? And it's very, very easy to go and test specifically if you think that's a problem. The last thing is that you'll have 6 strange things, really weird bug reports, or even in developments where nobody can explain. For instance, invisible UI elements. This is an actual screen from my product. It's a television product, and yes, it's in Russian. No, I don't speak Russian. If you want to, I'll have very funny stories later. But the UI states that you have 2 buttons, both of them with green background, ugly as hell, but what can you do? And when you press down on the D-pad, this focus should have been looking exactly the same only on that button. But what you see is this greenish mesh, no background for this button, but when you click it, it will do the action for that button. My developers spent 4.5 days trying to understand what it is. And then they came to me because I'm very busy and because they don't want to hear me talk for 25 minutes on one question. So I told them, have you tried hardware acceleration? And they said, what hardware acceleration? There's no animations here. It's just a standard 2-button interface. Doesn't make any sense, it's hardware acceleration. And then I said, did you try hardware acceleration? And they tested it, and it was hardware acceleration. And I'm going to get back and at the end and show you how you fixed it, and what the reason is for this was hardware acceleration. But you can see that you would never associate this with something like GPU implementation of OpenGL or whatever. It just seemed like someone didn't do their job. You'll get exceptions, really strange exceptions, usually on 1 or 2 devices specifically, usually involving memory, and none of them have any lines of code from your applications. None of them, which will make absolutely no sense, and you will not know why you're getting bug reports, because in the system track where you're getting, there is not one line of code from your applications. Hardware acceleration. And then you'll get these kind of things. We called the one on top Wolverine bug, because it looked like Wolverine came and ate the top half of the screen. And I don't know if you noticed this is an OpenGL gallery. I hate OpenGL, by the way. We don't use that anymore. But you have the entire Hebrew alphabet tagged on this poster for no particular reason. Again, 6 strange things. I was not kidding when I said that. And again, we're going to go back later, and I'm going to explain to you how we found that and how we fixed that. And that's, again, why it's so important for you to listen to me. So, is no one safe? Are we all doomed? No. Everything's okay. There are very easy ways to go around it. So, if you're using only standard views, and your minimum API level is above 17, you're in the clear. There's absolutely, there's almost no way for you to have these kind of errors, but still, you may listen. So you're probably thinking, wait, if I have a custom view, then I'm fucked? No, absolutely no. By the way, pardon my language again, I'm sorry. I don't control it. So what do we have to do? It's very easy. First of all, there's a list. This QR code is that link. By the way, this presentation will be on SlideShare in about 35 minutes, so there's no need to do anything. You can just take it. But this list is very important. It's from the documentation. It's not something I did. And it tells you what API level and what CPU and GPU family supports which part of the API. So if you have a custom views and it's using crop circle, which was only introduced in API level 16, I'm completely bluffing, by the way. There's no way that I remember that. Then your API level is above 16, you're in the clear. But if your API level, the minimum one, is 15, you need to start testing. So test on all available devices. Again, use the NDK design pattern and see the families. You don't have to test on every available device, because some of them use the exact same CPU and GPU, so they will act the same. But still. In Tel Aviv, we have in the Launchpad a device library, by the way, where you freely can schedule and come in and have all the available family, and you can test your application on it. I'm not sure if it's worldwide yet, but it's starting. They just gave it to London, so it's on the way. But there are also companies doing it for pay, and it's not that much. You just rent it out for a day, you test it, you see what's wrong, if something is wrong, and then you bring it back. So, when you test on all devices, you have special tools which nobody knows how to use. So, systrace is one of them. Systrace will tell you 3 columns, either with this wonderful GUI-like things telling you all these things, or in the command line with 3 columns saying how much milliseconds it takes for the Android system to prepare its asset, how much time does it take your processes to prepare their assets, and how much time is actually taking you to draw. If these 3 numbers accumulate to something which is larger than 16, you know you've got jank. So you know that in that screen, in that methodology, you have a problem that is related to the fact that you do not hit the vsync, and you have to. That's why you need to test it. Second thing to do is dumpsys gfxinfo, or dumpsys in particular. meminfo is also applicable. Application Manager is also applicable. It will give you all the information possible regarding how much memory, how much initialization of members and whatever you have in your applications by screen, and giving it in a very nice UI way, to the point when you can get, in some instances, how much time a method took to execute, which is unbelievable. It doesn't happen. So dumpsys gfxinfo would be the next thing I would do if I would find problem in systrace, or separately just because I want to. And if you're using, wrote GL Tracer, but I'm guessing that if you are using OpenGL, you'll be using much more sophisticated tools. But I meant TraceView, which is also another tool that a lot of people are not using because they don't know how. Now, I don't have enough time in this lecture to show you how to use them. That's why I used a really good friend of mine who has done this already, and the entire session is about how to use these tools. And he's a great guy. He's now the developer relations manager for Google in Israel. He's a really great guy, but he started as an Android GDE. And that lecture is worth its weight in gold. If I had time, I would do that as well, but I don't. So, if you found bugs, by the way, this image, if anyone can tell me what the origin of it, I found it on Google Images, and it was so funny, I put it in every lecture I had. I absolutely have no idea what it means, but it has bugs in it, so it's applicable. So if you found them, what would you need to do? What are the cornerstones? What are the things you need to check? First of all, reduce the number of views. If you found that you have jank, it is possible that your process is the one who's taking you above 16. And it is possible that it's doing it because it has too many views to do. So if you reduce the number of views by, let's say, a very good example that I see in almost every mentoring session. You have some sort of relative layout, and then you have a list view, which is deprecated. Don't use it. Use your cycler view. It's much better. And then you have, before that you have an image view for the background of the screen, and then you have a list view. Why? Why would you do that? I see it all the time, and then people say, no, they copy it off the same tutorial, which dates back to 2011. I hate that guy. If I met the guy who wrote that thing, I would absolutely slap him or her. I don't know, it's gender unbiased, because that's just not good. That's not efficient. You have no reason to add another view just to have background. But these are the kind of things that people ignore because they say, it's working okay. There's no reason to suspect this is what's causing anything. Well, now you do. Now you have reason. Second thing is avoid overdraw. Overdraw is when you paint a pixel more than once. How am I doing on time? Okay. So I'm going to speed it up because I'm a little less far ahead than I thought I was. Developer options have a way for you to see the overdraw in your application, meaning that if it's transparent, you're only doing it once. You're a hero, way to go. If it's bluish, it's twice. If it's red, reddish, really red, devil red, or whatever you're painting it, times 3, 4, 5, 6, 7, 8, 9, 10. If you're seeing that, just go home, come back the next day, and start evaluating, because if you did that, you're very tired. So developer options will tell you if you have a problem in that aspect. Then you can go to Hierarchy Viewer. Hierarchy Viewer will not only help you reduce views that you don't need, you can also click and download the screen layers. And then just like in Photoshop, you can see what's being drawn on top of one another. And if you have something which is, you have like a coloring the entire screen and then filling it with everything where you can't see the background to begin with, remove the background to begin with. That's one time that you're removing from all the views in your application just by doing theme background transparent, which is like 10 characters. So, but nobody pays attention to that. So fixing it, as I said, merge and remove layers, like removing the background where you can't see it, and like removing views when you don't need it. Second thing is crop and remove unseen pixels. So for instance, who here in their application have a background for an image where the background is sort of transparent and the image covers most of the thing because it's a background for the view holding it? How many people? Wow, you're very good liars. So the point of it is to take this image and just do, it's a 9 patch, so it's being stretched out. If you do a few transparent pixels at the middle where the image is always there, then it will stretch out to look like you tear a t-shirt, and it will not draw where the image is. That will save you like 40% of the image size just by doing 3 transparent pixels. Now, if you put transparent pixels in bitmaps, i.e. the PNGs that you're loading in, not the background, something that you actually draw that transparent, it's in the count. You're not scot-free. You need to actually crop it in order to not count it. But that's the least of your problems, really. It's just a good tip. New is bad. Just like in GetView and List Adapter, I see a lot of people doing new paint or new path in a method which runs 60 times a second, which means that 10 seconds you have 600 objects, which are very big, like path or paint. Don't do that. Use a member and then set path or paint. That will save you a lot of GC cycles. Now, GC is very expensive. It runs on your UI thread, on your CPU resources, and it runs a lot, because when you see 60 objects per second, which are no longer usable because they don't have a pointer to them, you will run GC. So, member, new path, new paint, and then set them in the onDraw. Makes a lot more sense to me, at least. Shapes, circles, and paths, oh my. These kind of objects, when you set them, they also create a new bitmap which is loaded to the GPU. So set them whenever you need to, because it's still better than you, but only set them when you need to, which is important. We're engineers, most of us. I'm not, because I was thrown out of school, but most of you are engineers. And the best thing about engineering is that we're lazy. We only do what we need to. Same thing goes with code. Be lazy. Let your code be lazy. That's good. So, yeah, alpha animation is the only animations where you do not reload anything to the GPU. It just changes the value of the bitmap in the GPU. So whenever you're doing alpha animations or alpha views or alpha something, you need to be using hardware acceleration. Ever. Anywhere. Unless your target audience is Froyo devices that grandparents above 65 use. Okay? Always. Okay, you remember the 6 strange things, the invisible things, and these were custom views for some reasons, because my developers really like custom views, and they fixed it with this little example. The not is in edit mode, meaning that whenever you needed to edit something, because you created it dynamically, again, it was very, very wrong of them to implement it that way, but we caught it too late. You simply use software layer. And in the software layer, you can draw whatever you want, but you only reload it to the GPU when it's final. Which means that because we added this, then if I come back all the way there to the reason that this, I'll continue talking until I know where I can stop here. This was loaded into the GPU when we found it 1,349 times. I remember this number because I said, oh my God. Because it was always in hardware acceleration, and these are new buttons that were not using the same kind of, this little background, this ugly greenish transparent background was more than 1,000 times in the GPU. It clogged it completely, so when they tried to upload it again for this one, they had no room. See how simple it is? 3 lines of code. Going all the way back to the front. Wow, we covered a lot. Okay, using control. When you think you have a problem with hardware acceleration, first of all, try it. So you have various levels of control. Applications is pretty straightforward. I do encourage you to do it once and run your application just to see the difference that hardware acceleration makes. Your application will almost not move if you do this. But it is a good tool to see if something is hardware acceleration oriented. When you have to do the application true, because the application itself needs to have hardware acceleration, but you can remove it for a specific activity if that one is acting up, which is pretty easy. You can do it by window, but you can only do it by window by adding. You cannot disable once you enabled it, at least not yet. Again, it's mostly for testing, and as a last resort, if you cannot find anything else to do, like everything that I've told you before, then remove hardware acceleration. But it's a great testing tool to see if it's hardware acceleration, because it's like, the wind and the leaves. You have no idea. You see something, you're looking for a reason. There's absolutely no way for you to guess it yourself. And you can do it for layer, where you can put view layers type software. Again, you currently cannot enable hardware. You need to enable it for the application and the hardware, and only then this will work. Now, I mentioned layers, so you have the layer type none. It's not backed by anything. It's being drawn by the software layer. Pretty straightforward. The hardware one is a tricky one, because most people think, hey, I put layer type hardware, it's hardware accelerator. No. You have to put enable true on the activity and the application for it to work. Otherwise, it will simply be software accelerated, and then you'll be more flustered. You say, but it's hardware accelerated. It doesn't make any sense. Well, it does, because you did not read the documentation or listen to this lecture. Hardware acceleration is, as I pointed out before, very good for performance, because drawing is delayed only when the system wants it to be, and because some animations like alpha do not require any resources, so it's a lot easier, and alpha animations are pretty big right now. Software, using a bitmap as a buffer instead of a texture buffer, whatever it is called. So as you can see, bitmaps are pretty big, they're pretty bulky, so software layer type is pretty expensive, but it's very good for compatibility. Again, if your minimal API level is below 11, or at this point, or if your GPU, or if the bugs that you see in your application are coming from devices which their GPUs and CPUs do not support the custom view that you have implemented with, I can't breathe, then use software layer. Now, how do you know if a view is actually hardware accelerated or not? You have two getters. One is view is hardware accelerator, and the other is canvas is hardware accelerator. You're saying, so which one should I use? You'll use the second one, because the first one is a liar. View is hardware accelerator only gives you the right answer if the layer itself which is sitting on is hardware accelerated, and you have no way of knowing that one. So just use canvas is hardware accelerated. It'll give you the right answer. So, key points. Notice how many people and franchises I ripped off throughout this presentation. This is from Mad Men. I stole things from everywhere. It's okay. I didn't get sued yet. So hardware acceleration is good. You need to know and understand that, but it's not good all the time. GPUs are different, just like people. No, that's a terrible analysis. So use the strong points, and don't use the weak points. Duh. Less is more. Create only what you need. Set only what you need. Draw only what you can see. Because otherwise you're just wasting bits and images and making your application slower and more expensive. And constantly analyze, test, and adapt. All the time. When you add a new screen, you say, I don't need it, I'm using exactly the same. No. You need to continuously analyze and adapt, because the API levels are advancing, your code is advancing, devices are advancing, and it is possible that new devices will act poorly in comparison to old devices, like Qualcomm. They released a new chipset which destroyed my application on newer devices, even though they had twice the amount of power. Now, Qualcomm is a wonderful company, a very good company, but people make mistakes. That's it. Now let's go to the inspirational portion. I stole that from I/O 2 years ago and Mashable. And the point of it is, exactly like our distinguished speaker said, the most wonderful, beautiful things that humanity has ever created, and the best and most beautiful things that we will see in our lifetime have not yet been invented. These will be invented, implemented, and marketed by people like you and me. So go get them. Thank you.